everyone, and welcome to my digital storyboard about sense-making. To understand sense-making, it's important to look back on previous experiences to compare the old methods of teaching and engaging students in science to the new and improved method of sense-making. My science experience in early elementary school was limited. If we did participate in science, the teacher would do the experiments while we watched or would do one or two steps with their assistance. We didn't get a lot of time to think about the experiments, since the teacher would usually explain to us what the experiment was meant to demonstrate. In upper elementary, leading into middle school, we participated in science fairs. These were also limited as we did all the work independently, following the scientific method we were taught in class. We would come to class and share our progress with our teacher and maybe a friend or two, but science was done very independently at this time. When I got into middle school, science followed the same patterns of the scientific method, but we would begin to work in groups from time to time. In middle school, I also joined Science Olympiad and learned more in depth about science practices and about how to share your findings with a group to refine your thinking. My experiences are very different from what sense-making tells us. I would define sense-making as students figuring out how the world works using science practices and designing solutions through engineering practices. Students participate in these practices by creating models and sharing their ideas with a community to refine their initial ideas and broaden their knowledge. Sense-making is important because it involves being a part of a learning community where you can share ideas and explore topics using science and engineering practices. This is also more engaging and motivating for students. If you were to break sense-making down into 3 big ideas, I would categorize them into phenomenon, science and engineering practices, and sharing ideas. Phenomenon is the first of the 3 big ideas and can be defined by natural events that occur in the universe that students can use their science and engineering practices to explain and predict based on evidence. Phenomenon is usually what is used to pique students' interest and get them to start to think of explanations for the phenomenon. For example, the teacher could show students pictures and videos of the northern lights or the aurora borealis, which would be fascinating for kids who have never seen this natural phenomenon before. Using sense-making, these students will be able to use their science and engineering practices to explain the phenomenon. This brings us to our second big idea, which is science and engineering practices. Science practices can be defined as understanding how scientific knowledge develops. Having direct involvement creates an appreciation of the range of approaches for investigating, modeling, and exploring the world around them. This is how students will be exploring the science behind the phenomenon, investigating using their ideas, and modeling their knowledge to other students. Engineering practices are when students have an understanding of the work engineers do and how to do the science required for exploration. This involves students understanding what skills are required to complete an exploration to make sense of the phenomenon. The last of the 3 big ideas that make up sense-making is the ability to share ideas. This can be broken down into 2 sections, student ideas and science ideas. Engaging in student ideas is to be social in the classroom by sharing and building on each other's ideas to give and receive feedback is essential to scientific practices. Science ideas are core ideas that are essential for complex science and engineering practices. For these more complex ideas, you would provide students with a key tool for solving problems related to their phenomenon. To wrap up this storyboard, I want to reiterate why sense-making is so important. It wasn't that long ago that I was in an elementary classroom learning science, and so much has changed since then. The science my peers and I experienced did not allow for expression, didn't offer many hands-on opportunities, and definitely didn't encourage motivating science or engineering practices. With sense-making and the 3 big ideas associated with it, students are encouraged to come up with their own ideas when given a phenomenon, and get to be scientists and engineers participating in those practices, and encouraged to be social to refine their ideas and original models to make those first ideas even better. I will definitely be using sense-making in my classroom for the future. I will use phenomenon to prompt students' thinking by showing videos or having them participate in demonstrations. I'll have them use science and engineering practices to create their own models and come to their own conclusions and teach them how to share feedback and ideas. It can be difficult to give or receive feedback, so I'll have procedures set in place so feedback can be given in a respectful manner. Thank you so much for listening to my storyboard about sense making.